In this module, we will be adding the logic for crouching to our first-person player character. We will repeat some steps from the previous module and do some new things. For example, in this module we will start using a timeline, which will allow us to gradually change a variable over a set period of time. In order to add crouching, we need to repeat some steps of the last module. So we'll go to Settings, Project Settings, Engine, Input, and we now need to add a new action mapping for crouch. So I'm going to go ahead and call this crouch, and I'm going to add one more action. The first one, I'll look for C. Just look for the C on the keyboard. There we go. For the second one, we'll look for Control. I'm going to go with left Control. So now we can either press C or left Control in order to execute the event crouch. Let's go back to our first person character. We can now right mouse button and look for crouch. Compile and save. Now what we could do is call an event called crouch, which is similar to jump. There's already crouch settings on the character movement component, but that crouching snaps and we want to have a smooth crouch, so you'll go down smoothly, and we want to do it ourselves. So we won't be using that method, we'll be doing it ourselves. A lot of this is also similar to what we want for the maximum walk speed. So we can actually go ahead and copy some of this. Copy these 4 nodes. Ctrl C, Ctrl V. So when we press, we update our maximum walk speed. When we release, we update our maximum walk speed. We want to create a new variable for maximum crouch speed. So we can, again, Ctrl W, max sprint speed, and we'll just call it max crouch speed. Compile and save. Let's put that to 200, which is half of our current default. Drag that out, get, connect it to the max walk speed, compile, save. And now when we press play, we can walk around, and when we press C, you'll see that he'll slow down. This is not really crouch, we're not really moving up or down, and we want to add a smooth motion of going up and down. So what do we need to do in order to achieve this? Let's go to our viewport and have a look. So we have our camera. What if we move that down? Well, the nice thing about the first person character template is that everything is attached to the camera. So if we move down the camera, Ctrl Z, you can see that everything below it moves with it. So basically we need to update the relative location of the first person camera. So right now we can see it's 64, and we want to move that down and then back up again. And in order to get a smooth motion, we'll use something that's called a timeline. So right mouse button, add timeline, enter, and there we go. We will name this timeline T_crouching. Move it up a little bit. And as you can see, there's a lot of different inputs here. There's play, play from start, stop, reverse, reverse from end. Sometimes it's best to call play from start. Sometimes it's best to call play. In this case, we will want to say play when we press it. And then when we release it, we can reverse it. This way, you can get a smooth motion when you're still in the process of crouching, but already want to stop crouching again. Let's actually open this up because we can go inside of it. Just double click it. And now we are inside the timeline and we can define it. So at the top here, we see a bunch of buttons and then we see length. How long should it take for us to crouch down? I think 0.5 seconds is a decent amount of time. Just press enter. So we want to gradually go from value 1 to value 2. What we can use for that is a float track. So click the float track button and name it crouch alpha. An alpha is usually a value that goes from 0 to 1. Either it's completely transparent or it's completely visible. A lot of times you'll go from 0 to 1. So that's what we'll do here as well. When the time is 0, we want the value to be 0. Let's add some values. Right mouse button, add key. So when we are starting, we want the default value to be there. Then after 0.5 seconds, we want the value to be at 1. We want the crouch to be completed. So right mouse button, add key to curve float, time 0.5, value 1. And here you can see a straight line going from 0 to 1. We can smooth this out a little bit. Just select both points, right mouse button, and then change the key interpolation to user. This will make it a bit smoother. This is usually always the better option. It feels better, looks better. Compile save. Now when we go back to the event graph, you'll see that a new output has appeared, our crouch alpha. We want to use this alpha to update the position of our first person camera. So let's grab a reference to our first person camera. On the output pin of this, we can now say set relative location. And then we drag out the update into the set relative location. What this means that for the duration of 0.5 seconds, this will constantly update the relative location of our first person camera. Now we need to lerp between two values. We'll go from value 1 to value 2. We can actually do that by dragging off of the new location and look for lerp. And there we'll see lerp vector. Press enter. I'm going to drag this out a little bit further. I'm going to correct this and connect our crouch alpha to the alpha. Now we need to know the values. Only our Z value is changing because we're going down. So let's have a look at our Z value. Click our first person camera. 64. You can actually copy, paste. Let's go down to 30. We need to make sure that our X and Y values are the same as well. So we can just copy, paste, copy, paste, copy the Y value as well. So over the course of 0.5 seconds, we will now go from our default position to our crouch position. When we press play, when we press C, you can see our character moves down. It's not that much yet. Maybe we can even put this lower. Let's put it on 0. Compile save, play, crouch, and now we can see he really goes down. And because we did play and reverse and not play from start, we can stop crouching as we're crouching, and it's always smooth. Always a smooth motion. Now, if you want this to happen faster, you can always update the timeline. An important thing to keep in mind right now is that we updated the location of our first person camera. We did not update the capsule component. So our crouching at the moment does not allow us to walk under obstacles because our capsule component is still as big. And we can use the same event to update our capsule half height. So in the event graph, you can get the capsule component and then do set capsule half height. We can lerp this as well. Use the same alpha. And then go from the default value of 96 to 50. Now, this will also have an influence on the camera because this shrinks. So it goes further towards the middle. So our camera will also go lower. Compile save. Play. We crouch, now we go super low. This is almost prone. Now that we have set the capsule half height, we don't really need the first person camera anymore. But it was interesting to have a look at. So we'll delete this, we'll connect the update to the capsule component, clean this up a little bit. And now we need to make sure that we can check if we are crouching or not. So we can select is sprinting, Ctrl W to duplicate and rename it to is crouching. Let's drag this out a little bit and set is crouching. So Alt drag. When we are crouching, this needs to be true. When we stop, this needs to be false. Connect it to here, connect it to there. Connect this, connect that. But now, let's have a look when we play. We can crouch, but as we're crouching, we can enable sprinting. So we need to make sure that that doesn't happen. Let's escape out of there. And let's add a custom event. Add custom event. And we'll call this stop crouching. Now this is an event that we can also call in our blueprint. We can use this to stop our crouching without updating our maximum walk speed. So let's connect this up to is crouching, set that to false. This will reverse capsule half height. Let's move over to sprinting. Let's extend this a bit. Let's actually select everything of crouch, comment it, crouching. Move this whole thing up. The comment also allows you to move everything at once inside the comment box, which is really nice in this case because we need to add some logic to sprinting. Let's go back to sprinting, extend this a little bit, extend this all, move this over, and we will add a branch. So you can look for branch. Because branch is one of those nodes that you use a lot, you can also hold B on your keyboard and click, and it will just spawn a branch for you. So when we press Shift, we'll need to do a check. When we release Shift, we'll need to do a check as well. So when we want to sprint, we want to have a look, are we crouching? So we can check the condition here, and we can connect is crouching. Hold Control, drag it out. If we are crouching, we need to stop crouching, the event we just made. Drag this out even further, make sure it all fits. We need to make sure to stop crouching. If we are not crouching, we can just continue as we normally would. And we also want to check is crouching when we stop pressing Shift, because if we are crouching, we don't need anything to happen. But we can just false. Only if we are not crouching do we want to update the movement speed. Let's have a look. Now we can press play, we can sprint, we can crouch, and when we start sprinting again, we will uncrouch. Now you can notice that it starts to get a little bit complicated, because now when we stop crouching while we're sprinting, it will still update our maximum movement speed. So we'll need to add another branch in our crouch, and when we stop crouching with the input, that only needs to happen if sprinting is false. Now one more thing we need to do here is on is crouching. If this is true, we still need to set is sprinting to false. That should cover all the special cases. So we run, we crouch, we start running again, if it stops us from crouching, we let go of crouching, we're still going. Crouching again, running again. So this is something important to keep in mind. The more input actions you add, the more complicated your code becomes. The more of the same nodes you call, the more you have to keep in mind all those locations where you call those nodes. For example, in this case, we have the maximum walk speed. We're calling that node in a lot of different places. So we need to make sure that they don't interfere with each other. We just added our first timeline to gradually change variables on our player character.